Hello, my name is Michael Moran, and today we are interviewing Professor Coach Dr. President Danush Dequarius Bathala and his lonely assistant, Dave.
Thanks for having us.
You're welcome. How's your day going?
Pretty good.
Alright, now let's get to the main part. So you were talking about viscosity and friction and your experiment behind it. So, what was the question you wanted to answer?
So one day I was sitting under an orange tree and orange fell and hit me on the head. And I was wondering, what affects the motion of the orange besides just gravity, you know? So that's when I first started thinking about viscosity and resistive forces and how that affects motion. So the question that I came up with is, how does viscosity affect the motion of a ball falling through a fluid, air, corn syrup, doesn't matter basically. How does it affect the motion of the ball bearing in this case? And the hypothesis that I came up with was that as the viscosity of the fluid increases, then the motion of the ball is going to be slower.
So, you keep talking about a resistive force. What in the world is a resistive force?
So a resistive force is actually a force that opposes the direction of motion. So, for example, in this case, the skydiver is falling downwards, aided by the help of gravity, and the resistive force is going to be drag, which is going in the opposite direction.
Now, is this related to viscosity?
Yep, so that's actually what I was trying to figure out in my experiment, how the viscosity and the viscous forces affect motion and resistive forces.
Is it related to friction in any way?
I think so. Our experiment, I'll actually save that for the end, but hold on a second. We actually got a call from producer Dan Douglas saying that there are no surprises in science and that we should present our results as they come in the experimental report. So yes, so we found out that as viscosity increases, the resistive force increases.
Alright, seems like you had to create an experiment to investigate this strange force, obviously. So what was your experiment?
I let my assistant Dave, who is working for above minimum wage, take care of the experimental design.
So for our experimental design, we went through 3 different mediums. We used water, corn syrup, and dish soap. And in those 3 mediums, we would drop a metal ball bearing. And then we would record it on a video camera and then use the tracker software to figure out its acceleration and velocity.
Okay, so what were your results? Did you collect any data?
Yep, so as all experiments, we definitely collected data that was verified by multiple trials. So in this case, these are velocity graphs for corn syrup, dish soap, and water. So as you can see in the corn syrup, although it looks like a tumultuous graph, the average velocity in this case remains constant, which shows that the object is not accelerating. In the case of the dish soap, we have a varying velocity here, as the object deaccelerates to the terminal velocity, you could say, in the medium, which is dish soap, and it's around a constant velocity after 0.15 seconds. In the case of water, because due to its relatively low viscosity, the object was actually accelerating, which means the magnitude of the velocity was increasing till the very end.
Alright, now that you have the data...
just one more thing, these are our graphs for acceleration. In this case, as shown in the velocity graph, the average acceleration averages out to be around 0, which means that the velocity was not changing. There was around a constant velocity. In the case of dish soap, we had initial acceleration, but then again, the graph averages to around 0, showing that the object had reached terminal velocity. And in the case of water, there is always an acceleration magnitude, a positive acceleration that shows that the object is constantly accelerating and deaccelerating, which means that it has not reached terminal velocity yet.
So now that you have the data, how does that tie into physics?
Yeah, so after thoroughly thinking about this issue, I figured out that viscosity definitely has to play a role in this, as seen by the graphs. We saw that as the viscosity increased as we went from water to corn syrup to water to dish soap to corn syrup, the velocity decreased at an increasing rate, which means the deacceleration was faster. I believe this is because of the different factors that affect resistive forces, viscosity, including surface area of the ball, where the viscous forces increase the resistive forces on the ball when the fluid was more viscous, as in the case of the corn syrup.
Alright, so were there any limitations or errors you found while you're doing this experiment?
Yeah, because I'm perfect, this experiment wouldn't have had any errors or limitations. But in this case, most of the experiment was actually done by my assistant Dave, so obviously we had some errors.
And with those errors, there could have been a few. One of them was the frame rate of the camera. It was not super high, so it might have caught the ball moving wrong, or it could have made it look like the ball was larger and messed up the data with how Tracker can track the software. The distances also could have affected. We might have not have been dropping them through enough of the medium to get to a terminal velocity, as what happened with the water. We did not have enough time to see it actually hit terminal velocity. Also, the starting points, we tried to keep it as consistent as possible, but sometimes we might have started a little bit too high above the medium where it could have gotten a little initial velocity before hitting it, or sometimes it could have been right on where the data would have been better, but because we were comparing it to a trial that might have not been done in the same way, it could make the data vary a little bit.
All right, so just to summarize, what's the main point you found from this experiment?
The main point that we found from this experiment is as viscosity increases, resistive force increases.
All right.
Just a quick word about our sponsors, without which this experiment could not have happened. I would like to thank Maya Roasted Sunflower Kernels, deliciously salted. And I would like to thank our producer and lights man, Sushil Hanumolu.